Okay, so we will start off. Hope everybody is fine, and in the interest of time, we will start off. Let me quickly share my screen. Okay, so we'll basically start off this session. As I mentioned, we will discuss basics on EC2 Lambda. We will go a little bit deep into Lambda because that is the one of the most highly used compute services, especially for short running tasks. And we will also understand what is serverless computing, containers, and a little bit on ECS and EKS. Okay, so not to waste time. So EC2, I think if you have used AWS in any way, shape or form, you would have at least heard of EC2, because that is this is one of the most oldest services in AWS. When even Lambda didn't come, even if standalone code you were writing and you were pushing to AWS ecosystem, generally it would be EC2, in those times, before people started using cloud computing, in totality. So it is one of the it is the elastic compute cloud is the full form, and the idea is that it is actually infrastructure as a cloud, and the what you can infer from that is it's a shared responsibility between AWS and you. That's how this is architectured, that the data center, physical hardware, etc., will be managed by AWS, and you would manage the guest OS, patching, security. If you remember, or if you are currently working in EC2, you would know that you would need to do the patching, that different OS upgrades, etc. So that is being managed by you, while that is not the case with Lambda. Okay, so this gives you more control with respect to the operating system you are having in EC2. Okay, so it gives you more control, as I mentioned, and obviously the major use cases are predictable workloads, legacy applications. As I mentioned previously, most of the applications were getting deployed or getting developed in EC2 before other services became more prominent, that is serverless computing. Okay, and you can make it scalable with auto scaling groups. We will little bit touch on this as well, how you can make EC2 more scalable and manageable. Okay, so that we'll look. Okay, little bit understanding the core of how the different engines where your code is running, compute is running, is architected. So you have basically three types. You call it the virtual machine, micro VM, which is a new concept, then virtual machine, and then you have container. Now VM is obviously EC2 runs on VM. Okay, it is the most traditional of the three, and it gives you security, it gives you access to control your guest OS, as we just saw in the slide. While in micro VM, it contains it basically gives you lesser control, but it gives you minimal guest OS control, and container is more, as you would have noticed, container is more towards EKS and ECS is what is being used. So it gives you the thing with containers is it's a shared OS and kernel with container runtime, and it is lightweight. Okay, so the thing with VMs is it becomes heavy because of all the applications running on its own guest OS. That makes it heavy. While in micro VM, with minimal guest OS, by minimal it implies that instead of having the entire infrastructure to get your applications going, you will have the lightweight alternates. Okay, for all the libraries and other resources getting installed in your OS. Okay, so it will all be lightweight, and because of being lightweight, it will be fast and secure. On the other hand, containers will anyway be lightweight because they are sharing the host OS, and each it's not that isolated. So if you think about it, container is one extreme and VM is one extreme. Micro VM gives you a combination of VM and container. Okay, that's why VM obviously is a new concept, and Lambdas and Fargate use micro VMs at their backend, while EC2 uses VMs, and ECS, EKS are container orchestration services, which help you provide containers for either of the engines, EC2 or Fargate. Okay, hope this is little clear. We can let me move to the next one. Now little bit touching upon serverless computing. Now if you are new to AWS, you would actually, this word little bit confuses people as to what is serverless. Does it mean that it doesn't contain server? So the thing is, it's not like that. So as you can see in your screen, it's pretty much pay only for execution time, which means with EC2 the issue is that even if, let's say, you have created an application, you deploy it to your EC2 servers, and there is nothing happening on your application, nobody is logging in and using the application, then also you will be charged because you have taken that server from AWS. While on the other hand, serverless computing, if no code is getting executed, you don't get charged. That is the biggest difference, and that's the biggest disruptor, I would say, in terms of cloud computing. That is because that makes a lot of difference, right? So you run containers on on serverless compute engine, or you run it on EC2 serverless compute engine, you only get charged when the code is being executed, while in the other one you anyway get charged with or without the code, right? So this is the basic definition of serverless computing. AWS Lambda is one of the services which uses serverless computing at the backend. So the AWS would charge you only for running the code with Lambda. Similarly, Fargate is a serverless service. Stem functions, SQS. These are some examples which I have given. There are other serverless services for which you have to pay only for the code execution time. Okay. Okay, little bit on the container services which we are having. So you have ECS, which is the Elastic Container Service, and then you have a Elastic Kubernetes Service. Now ECS and EKS are more competitors in themselves. ECS is a Docker based engine. Kubernetes is a pod. I mean the unit you call here is pod. Okay, and the biggest advantage of EKS is that it is cloud agnostic. That means it's portable. EKS can be ported to another cloud like a GCP or Azure. Okay, while ECS is more with respect to AWS cloud. Now, and what is Fargate? Let us quickly check it, and we'll go a little bit detail also. We'll see what are the different best cases for each of the different services we are talking about, and what are they not very useful for. Okay, so Fargate is basically a serverless compute we already mentioned for ECS and EKS. Okay, so and there is no server management required like you have to do in EC2. And it's ideal for bursty workloads and operational simplicity. So if you don't want to go into the nitty gritty of server management, go for Fargate. Okay, there is one, I think there is one. Yeah, Bilal.
Yeah, so basically, I wanted to ask that what's like main advantage of like using ECS over EKS? Means I got it that EKS have its own advantage.
Correct.
So why the ECS service exist? If I can build something and then transport data onto Azure, so why the ECS is there? Is there any advantage of using it?
Correct, correct. So, advantage of using ECS is that it's more simplified, lesser server management is required. Okay, EKS is more exhaustive microservices architecture. Okay, so if you have a very simple app which doesn't require that much complication you want to go into, then always go for ECS. But you still want microservices architecture, but the complication is lesser, then you don't want to manage it yourself. You would want it, the AWS to manage it at the back end with respect to the resourcing and everything. EKS becomes more, it gives you more control, and it adds to the complexity. So if you have a complex app, then definitely EKS is the better option. Okay, but if it's like, let's say it's not that complex and you don't have that many services internally in that application, and you still want container based service, then go for ECS. Got it? That's the idea.
Yeah, understood.
So I mean, it's a trade off, because you have applications ranging from being startups to being enterprise level, right? So if it's an enterprise level application, where it's really became complex after years of iteration, then they would definitely be on EKS, as I understand. Okay, and especially legacy applications. Previously, since ECS is a new concept, so older companies, older code bases would be using it less. EKS would have come in first, so they would be continuing on EKS, and anyway it supports cloud portability. Okay, so that's why generally you would want to go with ECS versus EKS.
So
Hope I,
does the AWS also charge differently for each services? Like ECS and EKS both have like different charges.
of course, yeah, 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 yeah. There are charges depending on the different features you are taking. Okay,
Okay.
uh, EKS becomes more complex. It gives you more control. So correspondingly, it would be charged little less, because now the nuances is on you. You are managing it, right? AWS management side would be little lesser. So correspondingly charges would be little different. Okay, so if
Okay.
management from AWS increases, so they would add to that charge, based on the code being run. So there are other parameters, but that's how it happens, right? If you are managing it, then that much cost is not incurred by AWS. Think of it in that way, right?
Understood.
Yeah. Okay. Okay, one second. Can you see my screen? Yeah, we are here. So yes, so basically, architecture wise, there are two layers. One is the orchestration layer, which is managed by ECS or EKS. Okay, so ECS, EKS are more orchestration engines. As I mentioned before, they manage, schedule, scale, and they provide all that. But they are not compute services as such. They are more container services, but they are not compute services. So ECS, EKS, you still have to use either EC2 or Fargate to run your code doesn't run on EKS directly. Okay, so internally you would have either EC2 there or Fargate as a compute option. I think I already mentioned EC2 gives you more control. Fargate provides AWS managed serverless compute. Okay, so that's how they are different. Um, and ECS, EKS, they manage the orchestration. Waiting room, still people are there. Okay, moving towards AWS Lambda. I think you would have all at least heard of this if you are in tech background, maybe not worked in it, and also got scared of the name. But actually, it's not that scary, and it is one of the most simple to understand. And if you know the use case, then you would mostly your code would be written in Lambda only. Okay, and again, it's serverless compute. You just deploy your code, and internally AWS Lambda runs it and scales it. Okay, and it supports various languages like Java, Python, and any of the languages you can choose, write it and push it off. And as I mentioned, you just have to set the memory size, and based on that, Lambda itself will provision the CPU, network, disk input output required. Okay, so if you provide more memory, which means you are ready to incur more costs, then you will get more faster execution. That's the trade-off. So if you are ready to incur more, you have more budget, then obviously you would want more speed, right? And what is Lambda layers? Lambda layers is basically a shared package which can be used by different lambdas you are having. Each Just a second, I think there is someone at the door. One second. Okay, sorry about that, guys. So Lambda layers, it helps you. Let me start my video as well. It helps you give that flexibility of sharing the dependencies which which different lambdas may be using, to avoid unnecessary imports, and common library usage. Okay, so lambda layers is a very common concept in Lambda, and you should definitely go for it if you want to also reduce the cold start. So we will come to that when we go into the little bit details into Lambda, how you can reduce the dependency imports, and help in reducing the cold start. Okay, so this was about Lambda layers. I think we already saw the basics of Lambda, and just to quickly touch upon the best use cases for Lambda, mostly short-lived tasks which doesn't take, let's say, minutes to process, minutes to hours to process, few seconds to process. You would always, Lambda is a good candidate for you to use. And ETL related jobs, extraction, transformation, loading. And then you have scheduled jobs, jobs which are scheduled, and which would happen at a specific time. Short running jobs, definitely go for Lambda. Okay, and little bit looking into the life cycle of different stages in which there are the Lambda code execution happens. So you have init, you have invoke, reuse, and shutdown. Okay, so init is something where it initializes your dependencies, and this is where the cold start happens. And invoke is where the actual code runs, and then you have the reuse, and shutdown is when the Lambda is shutting down. Okay, so just to that's the idea. Just to quickly check upon, we will come to this, we will come back to this slide in a bit. So init phase, it's the first invocation. When it happens through the init phase. Okay, it internally Lambda creates the execution environment, it loads the function code, etc. all the different dependencies related to the different library imports, like let's say you require some kind of dependencies for you to run the code, for example boto3, right? So all those initializations and definitions, they happen with lambda init phase. Okay. And cold start is the time when these things. Okay, I'm just trying to admit this person again. Cold start is the time needed to bootstrap the environment. So whatever time is required for you to initialize these dependencies, as I mentioned, or variable imports, database connections, everything happens with cold start. This is the meaning of cold start, the time it takes to do this before the code actually runs. Okay. So what is there to optimize here in Lambda is how you can reduce the dependency imports, because a lot of times these imports we don't give that much importance, and then they add to the they are added to the libraries, they are added to the to the initialization, and then finally they hamper or take more time for the entire cold start to happen. Okay, so that is something which we should avoid. I think this is what typically I wanted to mention for init. Invoke, I think mostly it's self-explanatory that it is where the Lambda handler actually runs for each invocation. And the thing is, the execution environment which initially got created after a long time of inactivity of the Lambda will stay warm for a short time. So if in 5 to 10 minutes you are having multiple calls being made to Lambda, there is no specific time AWS tells when the cold start would terminate or the shutdown will happen. Typically 5 to 10 minutes is the time. So within that time range, if another call is getting made or multiple calls are getting made, then again cold start will not happen. It will be warm only. So again initialization won't happen. That's the importance of init phase. So directly invoke or your function handler will run, and execution environment will be available as it is, and that's how the context would be reused. It's basically the same thing. So you would use the database connections, the imported libraries, global variables, etc., whatever were there in the whatever were initialized in the init phase. Okay. And what is the advantage of having this cold start available or the execution environment being warm is that you reduce the setup work. Now the next time your code is running, it won't take the time it took for the first time, which included the cold start. So it will just be the function execution time, right? That's the advantage. And along with this, there is a temporary storage which Lambda internally provides for you to because a lot of times you would store some files somewhere for you to do some calculation and come back to it later. So it provides you a temp directory, and in that directory it provides you 512 MB of storage. In between while you are coding and you want to store something and revisit it, so you can use this 512 MB of storage for that. Okay. Moving towards the shutdown phase and the Lambda layers. Shutdown phase is when AWS terminates the execution. Let's say for 5 minutes there is no call being made. Then what would happen is since Lambda is a serverless engine, AWS would try to remove or terminate the Lambda execution environment, and so that it could use those resources in some other way, shape or form, right? And now if another call gets made after 10 minutes, then cold start has to happen. Okay, that's the beauty of Lambda, that if multiple calls are happening after the cold start, those will take lesser time. Then if there is an inactivity, some period of inactivity, then the cold start has to happen, and the environment variables, the libraries will again get really initialized. It will create the execution environment, and then again the same thing continues for the next few calls. Within those 5 minutes, it will the environment will remain warm, and the initialization and the the dependencies won't get imported again. Okay, so and in the shutdown phase, Lambda clears all the initialized resources. I already mentioned that. Lambda layers, I think we already saw. If you have to basically share those external dependencies which you think would be used by other lambdas, then put them as zip files, and you can basically configure it in your settings, whatever provisioning mechanism you are using, Terraform or Cloud Formation or SAM. You can provide that configuration to use Lambda layers, and it would start using those dependencies common for the different lambdas. Okay, that's the advantage of Lambda layers. Okay, that is what I think I wanted to cover on Lambda. Hope most of the very major points we covered. A little bit on ECS now, best and worst case scenarios for you to understand what's the best use case for each of the different services we are talking about, as we saw for Lambda. So best for Docker microservices and AWS support focused organizations. As I mentioned, ECS is only Amazon oriented, and it's not cloud portable. So if it's a AWS focused application, then go for ECS, because you will get more I would say more the compatibility with different AWS services would be more with ECS. Just to answer your question, Bilal, that is also one of the reasons, because since AWS is the parent organization which is doing ECS, so if your other services are also more AWS focused and you're not looking to go to other clouds, then why worry about going with a more complex Kubernetes, right? And as I mentioned, if you want a little simpler alternative for management, Kubernetes management, it requires a lot of hand holding at our end. So you have to keep on configuring, and there are a lot of steps you need to do manually with respect to ECS, but obviously it provides control, so that's the trade-off, right? So it has lesser operational overhead, as I mentioned. So if these are all the use cases which fit your needs, go for ECS. Otherwise, the other option, if you're going towards more complex stuff and it is more custom towards your requirements, and your, let's say, user base has increased, it has become it is going towards more custom solution, then I think Kubernetes is a better solution in that way. But otherwise, ECS is good. And obviously, all these different services will have any of the above containers running. These are good examples. Little bit on AWS Fargate also we will touch upon. By the way, till now, anybody has any questions? Sorry, what did I? I think this is the biggest problem with Zoom. Always, cold start and warm start. Okay. I think, Kiran, I already mentioned these scenarios. So if you joined in late, just to okay, you got it right. I think I've elaborated pretty well on that. Okay. Any other questions? I can take a couple of minutes before we move towards Fargate. Okay, thanks, Kiran. Yeah. Okay, let's move forward then. Just give me 1 second. Let me close the server. Yes, Bilal, please go on.
I just have a small question that when we basically, as you mentioned that in the cold start time, that basically when we start the functions, call the function, it start with a cold start where it can take a while to start the service. So what's the,
Correct.
like usual time it takes in the cold start and in the like warm case
Yes,
to
yes.
run any function?
Sorry, I couldn't get your. So you are telling that cold start it takes longer time is what you are asking in
No,
with
no, I'm
cold.
asking that how long it takes in the case of cold
How
start
long
and
it
like
takes. So see, it depends on how many dependency imports are there. Okay, what is the size of your requirements.txt, right? So it depends on that. But yeah, I mean, if it's a typical 4 to 5 different dependencies you are having, which are the basic pandas, and if you have those basic libraries which you are importing, then it should be fine, like within maybe 10 to 15 milliseconds. I don't have the exact time, but it all depends on
okay,
the
okay.
dependencies.
Actually, I was just like worried that what's the like availability of these things? Like if I'm triggering, then how long it will take to exactly run it? In the case of cold start and the case of warm start.
Yeah, so
So warm start, I got it. If the things are already running, so it will run quickly.
yes,
But in the
yeah.
case of
So
cold start,
imagine warm
mhm,
start, like you don't have to get the database connection again. You don't have
right,
to import that library what you are going to use again. So that much time is saved. That it is already there in the in your context environment.
right.
But with cold start, you just have to add these time which it took for you to import all these different dependencies. And exact time why I cannot tell is because it all depends on how many imports you are doing. So if it's a huge list, that is why it becomes all the more important to optimize that list. It shouldn't be redundant. If you are not using a particular library, you have to make sure that it is not there in that in your code. Okay, that's the idea. Okay, moving on. Can you see my screen? Right. Okay, moving towards Fargate. uh, so this is a serverless engine which helps you, which lets your docker workloads, which helps you run docker workloads without managing servers again. So the headache at your end, operational overhead, becomes less while you use Fargate. And AWS only charges for what the code is running. It's again serverless. Okay. And it allows you both containers as well as EC2. Sorry, it allows containers in terms of EC2 and EKS to run at its end. Obviously, EC2 is the would be wrong. Saying EC2 would be wrong here, because EC2 is like a competitor of Fargate. Okay, so either you use EC2 or Fargate or Lambda. These are the three compute services you have at your disposal. And if you want serverless, go for Fargate. If you want more control, go for EC2. If you want short running tasks you are having, which you think could be quickly done, then go for Lambda. So best and not that best scenarios for Fargate would be, it is good for microservices with serverless containers, ECS, EKS, anything, uh, you know batch jobs. And if you don't want to manage EC2 complexity, then go for Fargate. Okay. And obviously not very ideal for very large Kubernetes clusters, and if more complex application is what, or workloads is what you're looking at. Okay. So these are the trade-offs which you would need to think. If your application is moving towards that scenario, then few instances Fargate also won't be that good a fit. If you want more control, you are at that level where you want control over the guest OSs, then go for EC2. Then you cannot go for Fargate, okay, because it provides you those things you cannot control with Fargate. And it's like very common nowadays with applications where you want to quickly start, and initially the complexity is anyway less, so you start off with a microservices architecture with Fargate at the backend, using ECS again for simplicity, and taking it from there. And as you move along, if you think you want cloud portability, then you maybe switch to EKS, and let's say you want more control, then you move towards EC2. That's the idea. Again, EKS is very much, I would say, similar to ECS, just that it is cloud portable. It is best for Kubernetes workloads and multi-cloud portability, as I mentioned. That is the major advantage of EKS. And as when I was answering Bilal, I mentioned that it is best for enterprise platforms, which are huge, really different services. Let's say one service for orders only, order processing only, one service for payments, like would be happening with all the bigger companies like Facebook, your Netflix, all these different bigger companies, YouTube, etc. I would think that they would be using Kubernetes only, because the complexities have become complexities would be of that level that Kubernetes at that point would be a good fit. So 100 plus microservices, if your number of services also is quite huge, okay, now if you have 100 plus microservices, even for small a dashboard which is related to, let's say, orders history, you have one service only for orders history, and so imagine the number of services you will require. Let's say you are somebody like Amazon, you think that it is just an e-commerce company. What is, I mean, there is a cart, there is a shopping engine, but ultimately, since it has become so huge, internally for even smaller even there would be one service only for cart, okay, and multiple such services to allow for fault tolerance. So that is a good example of when you can use EKS. I think EC2 we already saw, but just to quickly look at it. It is one of the oldest services in AWS. Legacy applications would still be on EC2 if they have not made it serverless, and the applications that require OS access, you want control over operating system, the different upgrades happening on the operating system, you want to host your own databases, that or specialized workflows. So that is the best use case for EC2. And obviously it's not ideal for smaller or simpler workflows, event driven systems, like is the case with Lambda. So if there is a file you are pushing into S3, and that file should trigger some code which does some processing on that file, or does an update on the DB, then that for that workflow you wouldn't use an EC2, you would use a Lambda rather, for a event driven system. So if for a particular trigger you are just wanting to run some small lines of code, then Lambda is a good proposition and not EC2, right? So smaller and simpler systems, event driven systems, you wouldn't go for EC2. Okay, now I want to also little bit touch upon one of the highly used availability pattern in AWS, especially with respect to EC2, because still a lot of companies, a lot of corporates, they still are on EC2. So although we think of EC2 as being little obsolete, but the reality is that because at the back end lot of complex stuff is happening, okay, and for that kind of a stuff you want EC2 because it gives you that much control. You can control the security, you can have upgrades to your OS, which becomes very important, especially with respect to cyber security and what is happening nowadays with the different frauds which are happening, correct? Now EC2 in itself becomes really difficult to manage if you add application load balancer, which would be just after the the first point of contact when a call is made from from outside to your AWS ecosystem. So ALB would be in public subnet. Some people who know little bit about networking would know that ALB would come first, and then EC2. The best architecture is EC2 to be in the private subnet, so that it's secure and it's not reachable directly from the internet. And for scalability, you would have a ASG, which is nothing but auto scaling group. So there is one concept called ASG in AWS where automatically it adds or removes EC2 instances based on the load. So it identifies the load, that okay, now load has increased, so time for me to add one EC2. Otherwise without ASG you would have to keep on monitoring your Splunk or your Grafana, and you have to take a call when the load becomes high, or when users start complaining about the loader keeping on coming, then you go ahead and change it. So instead of that, if you want little bit automation to be there, then go for ASG with EC2. Okay, it basically adds or removes EC2 instances based on the load. So even it is removing as well if the load is less, which is really good, right? It helps you with the cost. And if it keeps on checking for healthy and unhealthy instances, so unhealthy instances it keeps on removing, something like that. And AZs is again, you can add AZs as well to this list, which is EC2 plus ASG plus AZs, which means multiple availability zones, so that if there is a connection or power failure in one of the zones, you still have fault isolation happening, because the database or your application is also there available via the another availability zone. So in a region you will always have multiple AZs, if so that's the idea. So typically if you combine these four, then it becomes a really high availability pattern. By high availability you mean that in spite of, let's say, failures, what is the probability of my application being available and not giving me a 404, is the meaning of high availability. So if in spite of the different failures which can happen, if still the application is available, that means that's an example of being highly available. And to make it highly available, you need to have EC2 ASG AZs combination. Okay, that's how you architect it. Okay, so it's a very important pattern. That's why I wanted to highlight here in this session. I think rest of the things are just more headlines. Okay, and just to quickly let me check if we have any questions. Okay, sorry about that. New AWS service called Lambda durable functions that handles long running workflows that last up to a year. Google. Okay. Yes, Kiran, that's right. And just to quickly touch upon, I think more or less we covered that. I'm just recapping it here, how lambdas and EC2 and EKS are different, because sometimes that's the biggest confusion. People mistake lambda with ECS and EKS, although ECS EKS are totally different concept. Lambda should be compared with EC2 or Fargate. Okay, so lambda is serverless, good for event driven architecture. It is auto scalable, and obviously it's pay per execution, good for scheduled jobs, jobs which take lesser amount of time, and not good for greater than 15 minutes. If any job is taking, then don't go for lambda. That's the red line. Okay, ECS EKS are more container orchestration engines. Internally they would want to use either EC2 or Fargate to run the code. ECS is more AWS focused. EKS is cloud portable. ECS is best for microservices, which is the thing for EKS also, but for large enterprises and complex microservices, right? So typically, that's the idea. And not good for multi-cloud. Definitely ECS is not cloud portable, and this one EKS is not good for very simple applications. Okay. Yes, Bilal, please go on.
Just to go on the question which I think Google have asked regarding running a function, Lambda function more than 15 minutes. I think if the reason why we avoid, you also I think mentioned that Lambda is
Correct.
good for less than 15 minutes. Is it because of the costing part? Because like when it run for longer time, its costing goes above using the Fargate or anything. Is that the reason or any other particular reason?
No, it
Like,
would no, for greater than 15 minutes. See, I mean, if it is very close to 15 minutes, it would still run. But with respect to, I think cost is also one of the factors. You are right. But at the top of my mind right now, what I would think is for batch processing, if you're asking 15 minutes, I think better to go for ECS in that scenarios. And see, if it's a one-off case where your job is taking 15 minutes, but average it is taking, let's say, 5 minutes maximum. One-off case, it is still okay with Lambda. But if it is, let's say, average it is taking 20 minutes for your job to complete, then Lambda is not a good scenario, because because of that the context environment, which is temporary here. Okay, remember that it's like AWS is giving you a context environment for you to make things simple. So when it makes things simple, so your code and your processing also needs to be simple. Now if you are making it complex, where there is a lot of processing going on, then your cost obviously will go high, because the code keeps on running. And then finally it is related to the memory. Okay, so that is the main point. It provides only that much memory at your disposal, right? So
yeah,
if
5.2 you mentioned.
which you have to select initially. Now if the time is going on the higher side, then again you have to increase the memory, which will increase the cost. So ultimately it goes down to the cost only. So what the recommendation is always with cost perspective, as you correctly mentioned, Bilal. So in that scenario, maybe ECS serves better, right? Because for 15 minutes, 20 minutes jobs, ECS is not a problem. But for Lambda it may become a problem, because you have limited memory to work with, and with that limited memory your latency increases if you are not wanting to increase the memory. And I think there would be a limit to the memory. You cannot just keep on taking it to an infinite level. Okay, that's why it's good for short-lived tasks. And ECS
Understood.
definitely is more scalable. Okay.
Understood.
Yeah. Okay, I think with the since we are on time anyway, I'll basically stop the session right now, and I'll share with you one small link. Just go ahead and fill that up. Basically, we have one community which we are building especially for AWS and people working in AWS, so that you have peer learning available. So go ahead and register in this form, so that we understand what kind of experience you are having, along with the community related details. There are other questions also being asked, so it gives us an idea what kind of demographic we have, and based on that we can try to have more events conducted and updates being sent in that group. So we have still not created that. We are waiting for more registrations to happen before it becomes paid. Ultimately, when we come to a level where where we can start charging, then obviously that is a little bit far away, but right now it is free. And you should enjoy the different leverage you get there by basically having your peers and getting the updates, and we'll try to do more workshops and sessions as well from time to time in that group. Okay, so go ahead and at least register and provide me your feedback, and we take it from there. Any other questions from anybody before we wind up? Okay, and one more thing is that this Thursday we'll do another session. It will be on, I think I want to do IAM because a lot of people missed that, and so I'm inclined towards doing it, because that's where the major challenge lies with people. And then we'll cover database related. Those are more easier concepts to understand. If you don't understand identity and access management properly, then the base is not built for you to service related knowledge. What we saw like today is more knowledgeable, is easy to grasp, but sometimes with identity and access management it becomes more confusing. So I want to have that session before we move towards database related part and the other sessions which we have. So mostly it will be IAM related. So hope anybody who who couldn't do it in the last one, please have it attended, or attend it, and hopefully it would be beneficial for you. Okay, thanks guys. Please provide your feedback in this sheet, because what I have noted is that all of you say nice words in the chat, but I see lesser feedback on the group and on the form. So whatever you feel comfortable, at least provide your feedback on the meetup group or on the form, whatever is comfortable for you, and we take it from there. Okay, this feedback helps me in creating more credibility, and it helps us in growing together, right? Thank you. Bye everyone. Yeah.